Good day, ladies and gentlemen. Welcome to Use Math Academy. Welcome to Use Math Academy. Today we're going to do something called geometric sequence. With this geometric sequence, all I need you to know is that the ratio of successive terms is constant. Unlike in arithmetic sequence whereby the difference between successive terms is constant, here we deal with the ratio, meaning that to get from one term to another, you have to multiply by that common ratio. So to set an example of that, let's say we have 7 as the first term, and then our second term will be something like 14, that term will be something like 28, and fourth term will be something like 56. Let's say we only have those, but we can still add other values here. Now, when we say the common ratio, we mean that the second term divided by first term, this will give us 14 over 7, and this gives us 2, right? And also the third term divided by second term, which is going to be 28 divided by 14, this will also give us 2. The same applies for fourth term dividing it by third term. This will give us what? Just 56 divided by 28. This will give us 2 also. Will also give us 2. Now, what happens is that to get from 7 to 14, we need to multiply by 2. To get from 14 to 28, we multiply by 2. But to get from 28 to 56, we also multiply by 2. That's why we're saying that this 2 is our common ratio. This 2 is our common ratio. Okay. Now, with that being said, if A, R is an element of what? A and R both are elements of real numbers, and we have something like N here, which is an element of a natural numbers because of N. N cannot be decimal, so something like natural number. It's a counting number. Start from 1, 2, 3, 4, 5. That's why it's an element of natural numbers. But A and R can be decimals. That's why they are an element of real numbers, right? Now, from then, with this information that we have, then what? Then AR to exponent 2 until AR to exponent N. This is a geometric sequence. Geometric sequence with n terms. This is a geometric sequence, the sequence with n terms, whereby A is the first term, R is what? Is the common ratio. This common ratio, we obtain it by what? By dividing n term by the previous term. That's how we obtain this common ratio. And we have something like the nth term, which is A to the exponent R, or A multiplied by R all to the exponent n minus 1. This is what we have. for a geometric sequence. Now from there, let's just go straight to one of the examples. Let's just go straight to one of the examples. The first example will be what? Let's say we need to find the seventh term. Let's find the seventh term of the sequence. 3:6:12 and blah blah blah. Alright, now with this sequence, the first thing that we need to do is to verify if this is a geometric sequence. We need to know the nature of the sequence we're dealing with, because we can't just say this is a geometric sequence without proving it. We have to prove that indeed this is a geometric sequence. To prove that a sequence is geometric, you have to divide the successive terms and find out if the ratio will be constant throughout the sequence. Now with this one here, we're gonna have to divide the second term by the first term. This will give us 6 divided by 3, which is equals to 2. And also what? The third term divided by second term. This will give us 12 divided by 6, which will give us 2. You don't have to do all the terms. Let's say let's say we have 5 terms in our sequence. We don't have to do all of them. We only do up until the third term. Because it's gonna take a while if we try to do all of them. So it's better to do up until the third term. Now with this, we know that our ratio is equals to 2. Since our ratio equals to 2, now we can say that this is a geometric sequence, just because our common ratio is equals to 2. We have a common ratio. Now it implies that this is a geometric sequence. Geometric sequence with what? With A equals to 3, R equals to 2. Alright. And N equals to 7. Remember, we have to find the seventh term, so we know that N equals to 7. But let's not forget that we have something like the nth term, which we know that this is equals to A multiplied by R to the exponent n minus 1. Now what do? We know that now we're looking for the seventh term. Since we need to find the seventh term, we have to replace that n by 7 and A by 3. And here is a multiplication. Here we're going to have to put 2 to replace that R. And as for the exponents, it's going to be 7 minus 1. Remember, n is equal to 7. Now this implies that the seventh term is equal to 3 multiplied by 2 to the exponent 6, which gives us what? Which gives us 192. From my calculator, it shows that this here gives us 192. Now it means that the seventh term that we're looking for is equal to 192. That's it. Alright, let's have another example. Let's do another example. Let's say we have a sequence like this. We have sequence like 1:1/3:1/9 and blah blah blah. And this sequence, they say it has a value of what? Of 1 over 729. Now what we need to do, find the position of this value. Remember, 1 is at the first position, 1 over 3 is at the second position, 1 over 9 is at the third position. Now we need to find the position of 1 over 729. To do that, we need, the first thing we need to verify if indeed we are dealing with a geometric sequence, because we might be dealing with arithmetic sequence or quadratic sequence. To verify if indeed we are dealing with geometric sequence, we have the second term divided by first term. This is going to be 1 over 3 all divided by 1. We have the third term divided by the second term. This gives us 1 over 9 all divided by 1 over 3. This at the end will give us 1 over 9 multiplied by 3 over 1, which gives us 1 over 3. This one here will give us 1 over 3. With these two statements or these two equations, we can say that our common ratio equals to 1 over 3. By that, it means that this is a geometric sequence. Now we just proved that we are dealing with a geometric sequence. It also means that for us to find the end term, which is 1 over 79, to find the position of the value of n, it means, since we have something like this, nth term equals to a multiplied by r exponent n minus 1, we know that the nth term is 729. 1 over 729 becomes the nth term. Now we need to look for the n value. We know that the first term here, which is a, we want to replace it by 1, and the common ratio is 1 over 3, since we know that. Then we say all the exponent n minus 1. This time we have no idea what the value of n, so we need to put it as n minus 1. Okay. Now we have a challenge here. We have 1 over 729 equals to, alright, let's deal with this guy here. 1 multiplied by any particular thing is that particular thing. So 1 multiplied by 1 over 3 to the exponent n minus 1 is the same as 1 over 3, just that we omit 1 here. Then let's write this one. Now we have a challenge here. We need to find a number we can raise we can raise it to an exponent to give us this 729. Now to do that, we go to the calculator. You say you press 729, then you press shift, and then you press button with these 3 dots just next to the hypotenuse button. By doing that, you will find that you will get something like 3 to the exponent 6. So it means that 3 to the exponent 6, this 3 to the exponent 6 equals to 729. So it means here we can say 1 whole over the 3 to the exponent 6. Why are we doing that? It's because the base in the other side of the equation is 1 over 3. Now we also have to make this other part of the equation to 1 over 3. Okay, we have 1 over 3 this side as it is. But remember, this base here of 1 over 3 is enclosed inside what? It's enclosed by the exponent of n minus 1. Now here we can also close this 1 over 3 into 6, and we can have something because of 1 to the exponent 6 is also equals to 1, so there is no difference. This side we have 1 over 3, we have n minus 1. Now with that, we have the same base in both sides of the equal sign. What can we do? By the laws of exponents, it means that if we have something like this, when the bases are the same, we equate the exponent. So this is from the laws of exponents. Given that x and x are the bases, then n and m are exponents. We can equate the exponents. Now it means here we're going to equate 6 to what? To n minus 1. Now to solve for n, we have something like 7 that's equals to n. Now it means that the seventh position or the seventh term is 1729. It means that 1729 is the seventh term of the sequence. Okay. Now let's carry on to another example. Let's carry on to this other example. We have this example again. It says that in a geometric sequence, the third term is 25 over 4, and the seventh term is 4 over 25. Now we're being required to find the first terms of the sequence. We have to find the first 3 terms of the sequence. Now to do that, we've been told that we're dealing with a geometric sequence by this statement here. So we don't have to prove that if we have a common ratio. We just have to assume that the ratio is common. Right? Now with that being said, we know that okay, we have this third term, which is equals to a to the exponent a to the exponent a multiplied by r to the exponent 2. We know that. And we have the seventh term as a to the exponent r, a multiplied by r to the exponent 6. Someone may ask themselves, where am I getting these things? A geometric sequence is like this. A is the first term, AR is the second term, AR to the exponent 2 is the third term, AR to the exponent 3 is the fourth term, AR to the exponent 4 is the fifth term, up until we get to something like AR to the exponent n. Okay. N minus 1, which is the nth term. And this one here is the fifth term. This one here is the fourth term. This one here is the second term, or third term. This one here is the second term, first term. Now that's why I'm saying that the third term equals to a multiplied by r plus 2. And we know that this third term is equals to 25 over 4. And we have this seventh term, which is equals to a multiplied by r to the exponent 6, which equals to 4 over 25. Okay. Now with that, you can have something like ar to the exponent 2 equals to 25 over 4. That's equation 1. And ar is the exponent a multiplied by r to the exponent 6, the power 6 of 6, which is 4 over 25. That's equation 2. Now, what can we do from there? Now, what you need to do is that in simultaneous equations of this kind, we divide. In simultaneous equations of this kind, we divide. But someone may try to do something else, may try to solve this in another way. But in this kind, I will prefer to divide. Or we can use something like quotation. The quotation rule of simultaneous is like this. Let's make the first equation as a equals to 25 over 4 to the exponent r squared. Then the second one will be as a equals to what? 4 over 25 r to the exponent 6. Okay. We have equation 1 like that, and equation 2 like that. Now, since both are equal to a, it means that this 25 multiplied by 4r squared is equal to what? Is equal to 4 over 25 multiplied by r to the exponent 6. Okay. Now, with this, to solve for r in this case, we have something like let's say we do something called cross multiply. We're gonna have 25 multiplied by 25 r to the exponent 6. This is going to be equal to 4 multiplied by 4 r to the exponent 2. Okay. Now 25 multiplied by 25, it's something like, from my calculator it shows that 25 multiplied by 25, something like 625. This is 625 r to the exponent 6, and this is 16 r to the exponent 2. Alright, to solve for r is the only unknown variable. Now we need to do what? We need to say we can do this r to the exponent 6 divided by r to the exponent 2 equals to 16 divided by 625. If I have to explain this, let me explain how I got this. How I got this is that since we have 625 r to the exponent 6 and 16 r squared. Okay, first of all, I'm going to have to divide by r squared, which is in this side. R squared, okay, r squared is r squared. Then in the same divisions or in the same equation, let me divide with 625 again from this side. 625 and 625. Now the 625 will give us 1 from this side. On the left hand side, we're going to be left with r 6 and r of this point 2, which is equals to, and the r squared this side will give us 1. We're going to be left with 625. That's what we have. Okay, now to carry on from there, we know that r to the exponent 6 over r to the exponent 2, this will give us r to the exponent 4. Exponent in the numerator, subtract the exponent in the denominator. We are left with r to the exponent 4 and 16. As for 16 divided by 625, this one can leave it like that. And okay, to carry on, we have something like alright, now we have to, since we have exponent 4 this side, we have to raise this 16 over 625 to a number, to an exponent 4. We need to have a number that we can raise to exponent 4. Now let's start with 16. To do that, we say 16, right? We say shift and then the dots, the button with 3 dots. This gives us 2 to the exponent 4. And then what about 625? Say 625 and shift button with 3 dots. This gives us 5 to the power 4. Now with that, we know that 2 over 5 can be inside this exponent 4. Okay. Now with that, we know that we have exponent 4, we have exponent 4 that side. There's the rule which says that if y to the exponent n equals to x to the exponent n, then the bases are different. We have different bases, but we have same exponents. It means we can equate the bases, just like the one which says same base but different exponents. In this case, we equate the exponents. Now, in this case, we're going to equate what? We're going to equate the bases. Then we're going to have r is equal to 2 over 5. We have our r that's equal to 2 over 5. Alright. Okay, let's carry on. Remember, we have to find the first 3 numbers. Our r now is equal to 2 over 5. Okay, but remember the first equation. The first equation is what? It says, okay, let's call this equation 3. Now we need to substitute this equation 3 into equation 1. Remember, equation 1 says what? Equation 1 says a equals to 25 over 4 r squared. Now this implies that 25 over 4 into 2 over 5, which is squared. This will give us what? 25. Okay, or something like 5 squared. Oh, alright, let's do this. we have something like 25 divided by 4 into 4 over 25, and we have something like what, 25 over 16 and divide by what, by 25. So this division is the one which is for the whole thing. Now with that we have 25 over 16 multiplied by 25. 25 divided by 1 multiplied by 25 over 16. Then we have something like 625 over 16. Then our A equals to 625 over 16. Our A equals to 625 over 16. Now the first three terms of our sequence will be what? Our first two sequences, okay, our first term will be something like, since we know that A is the first term, AR is the second term, AR squared is the third term. So means that we have 625 as the first term, and then 625 into 2 over 5, and 625 into 2 over 5 squared. This is our sequence. Then it's going to be 625 into 625 by 2 divided by 5. You can find that from your calculators. Then this side we're going to have 625 by 4 and divide by 25, and that's it. Those will be our first terms, our first three terms of a sequence, and that's it. I thank you. But yeah, that's it. Thank you from that. That's all we have for. That's all I have for a geometric sequence. I hope from this you can tackle any other question you find regarding the geometric sequence. Now, the next session is gonna be for geometric series. We'll be dealing with the geometric series. You need to know how to add these terms. Geometric series is just the same. It's just a sum of terms of a sequence. So you shouldn't be surprised. But you need to know these basics of a geometric sequence because we're going to apply them in the next chapter, which is for geometric series. And that's it from me, and I thank you. Don't forget to subscribe and share.